In this video, we'll be looking at how we can separate mixtures. Recapping the definition from the previous video, mixtures are made up of separate substances, either different elements or compounds, that are not held together by chemical bonds. So as mixtures aren't held together by chemical bonds, they can be separated via physical methods. The type of separating technique we use depends on the type of mixture that we have. For example, if we're separating a mixture of liquids with different colors, we'd use chromatography. If we're separating an insoluble solid from a liquid, and again an insoluble solid is something that does not dissolve, we'd use filtration. If we're removing a soluble solid from a solution, so a solid that does dissolve, we'd use either evaporation or crystallization. And if we're separating out a mixture of liquids, we'd use some variation of distillation. We're going to look at when to use which separating technique, what equipment we'll need, and how we can actually perform that technique. Make sure to learn the full methodology written in the blue boxes. The first separating technique we're going to look at is paper chromatography, sometimes called thin layer chromatography. We use this technique to separate out a mixture of liquids of different colors. The most common example is separating out an ink into its constituent dyes. So this is how it works. First of all, we draw a line with a pencil near the bottom of the filter paper. We use a pencil, as if we used a pen, the ink may interfere with the results. We put the spot of the ink we want to separate on the pencil line and place the paper in a solvent. We usually use water, but if water isn't strong enough to separate out the ink, we'd use ethanol. We seal the container and we wait for the paper to slowly absorb the solvent, and as the solvent moves up the paper through absorption, it carries the ink with it. The separate dyes that make up the ink will move up the paper at different rates and form spots on different points of the paper as per this diagram. Here we can see we started off with a spot of green ink, and as the solvent separated the ink out into its dyes, we got a black dye, a red dye, an orange dye, and a yellow dye. We stop when the solvent front reaches near the top of the paper. The solvent front is just the highest line that the solvent has reached on the paper, the highest point, sorry. So we stop when the solvent front reaches near the top of the paper, and we're left with a diagram called a chromatogram, which shows all the different dyes that make up the ink. So this diagram here is a chromatogram. We need to be careful here, as sometimes two or more dyes could end up on the same spot on the paper. So if our chromatogram has 4 spots like this one, we have to say there are at least 4 different dyes here. The second separating technique we'll look at is perhaps the simplest of the lot. It's just filtration. It's how we separate an insoluble solid from a liquid. We have to set up the equipment as shown here. All we have to do is get the mixture of the insoluble solid in the liquid and pour it through a funnel covered in filter paper. All the liquid will pass through the funnel and collect at the container in the bottom, and all the solid will remain in the funnel because it's simply too big to pass through it. Again, just like with every technique in this video, make sure you learn the method in the blue boxes. Filtration is fine when we're separating an insoluble solid from a liquid. However, the technique required changes significantly when looking at separating a soluble solid from a liquid. As a soluble solid will dissolve, it becomes much more difficult to separate and requires a different technique. We're going to look at 2 separating techniques that we can use when we have a soluble solid in a solution, like for example salt dissolved in water. If the solid we're trying to separate out does not decompose when heated, we'll use evaporation. If the solid will decompose under heating, we use crystallization. So evaporation is pretty straightforward. We simply put the solution we want to separate into an evaporating dish and place that dish on top of a gauze mat, which we place on top of a tripod. We make sure there's a Bunsen burner underneath to apply heat as per the diagram, and we slowly heat the solution until the solvent evaporates, leaving just the solid behind. You may have to dry the solid using an oven or a desiccator afterwards. Crystallization is very similar to evaporation. However, we heat the mixture less, as the solid we're trying to separate would decompose if we use the same amount of heat as we did in evaporation. We set up the equipment just as we did with evaporation, and we heat the evaporating dish containing the mixture slowly. When the solvent begins to evaporate, instead of following through and letting this happen, we're going to actually remove it from the heat. As the solvent evaporates, the solution becomes more saturated. There's now a higher concentration of the solid as there's less liquid present. When some of this solvent has evaporated, we will start to see crystals forming. This is what we call the point of crystallization, and this is when we remove the dish from the heat and let it cool. So because the solution has lost so much of the solvent due to heating, the solid will not be able to dissolve further. We say the solution has become saturated, and crystals will start to form. We simply filter out these crystals using filtration and then dry them using an oven or a desiccator. When separating a liquid from a mixture of liquids, we use distillation. If all the liquids in the mixture have very similar boiling points, then simple distillation will not be sufficient and we'll have to use fractional distillation. However, if the boiling points of all the constituent liquids in the mixture are significantly different, we can use simple distillation. To perform simple distillation, we'll need the equipment shown here. We simply heat the mixture until the liquid in the mixture with the lowest boiling point starts to evaporate. The vapor will rise up and move through to the condenser, where it will turn back into a liquid and be siphoned off. All the other liquids in the mixture with higher boiling points will remain as liquids, as they cannot evaporate yet. Do this several times and you'll have separated the mixture out into its constituent liquids via their boiling points. When the boiling points of all the liquids in a mixture are similar, simple distillation will not work, as more than one liquid can evaporate at the same temperature. This is when we use fractional distillation. We set up the equipment just as before, however now we have glass rods inside the fractionating column. We begin the process just as with simple distillation. We apply heat to the mixture until the boiling point of one of the liquids is reached and wait for it to vaporize and then condense in the condenser and be tapped off. However, as multiple liquids can have similar boiling points, more than one liquid may vaporize at a time. The fractionating column is cooler at the top than it is at the bottom, so the liquid with a similar boiling point will only get part way up the fractionating column before condensing and falling back down into the mixture. We then raise the temperature slightly and collect the next liquid, referred to as a fraction, and do this until we have the mixture totally separated out. This method is used industrially to separate crude oil into different fractions, such as petrol, diesel, and airplane fuel. If you guys have benefited from watching this video, please subscribe, comment, and like. If you feel like there's somebody who could benefit from watching this, please share it with them, and I'll see you guys next time. Peace.